Here are two events named A and B, and we are interested in three kind of situations. The first situation is A does not happen, and in math language we will write not A, and sometimes we write A bar. And the second situation is that A and B both happen, and we write the situation as in math language A and B. And the third kind of situation is that either A or B or both happen, and in math language that is A or B. And if we describe these events as sets, we can translate this not and or into the set language. Not A is the set A complement, and A and B is the set A intersection with B, and A or B is the set A union B. And what we are very interested in is the probability measure of these three kind of situations. And we know that the probability measure of A complement equal to 1 minus the probability measure of A. And if A and B are independent, then the probability measure of A intersection with B would be the product of the probability measure of A and the probability measure of B. And if A and B are mutually exclusive, that is to say, A intersection with B is empty set, then the probability measure of A union B would be the sum of the probability measure A and probability measure B. Sometimes the second situation is mentioned as product law, and the third situation is mentioned as sum law. And let's recap. Not is complement, and the probability measure is 1 minus. And is intersection, and if they are independent, the probability measure is product. Or is union, and if they are mutually exclusive, the probability measure is sum. Then let's use an example to see how these things work. This is homework 2, problem 5. In this problem, there are 4 components inside a system. One component is the controller, and 3 components are peripherals. And we are very interested in an event named up. And finally, we want to find out the probability of up. And we then also given the probability that each component fails, the controller fails at probability A, and the peripheral fails at probability B. So let's first define two kind of events. And event A is the controller fails. And by the description, the probability measure of A is A. And event BI is peripheral I fail. And I can be 1, 2, 3. And by the description, the probability measure of BI equal to B. And then we come to the event up. We want to find out what is this event in detail. And let's read the description very carefully. Up is the controller and at least two of the peripherals are functioning. So the first thing is the controller is functioning. So the event the controller fail is A, and then the event the controller is functioning would be A complement. And the relationship here is AND. It is AND is intersection, so intersection with everything else about the peripherals. The peripherals can have two kind of situations. So at least the two peripherals are functioning means three functioning or one fail and the other two functioning. And inside these two descriptions, three peripherals are all functioning means peripheral 1 is functioning, that is B1 complement, and peripheral 2 is also functioning, and its intersection B2 complement, and peripheral 3 is functioning, so intersection B3 complement. And this situation can happen, or the other situation can happen, so this would be union with other kind of situations. Inside this second kind of situation, one fails and two are functioning. This can be divided into three kind of situations that prefer one or two or three can be the one that fails. So we can write this situation to be the first situation, prefer one fails and the other two are functioning. So that is B1, and that is intersection B2 complement intersection B3 complement. Or so it's union. The prefer 1 is functioning and prefer 2 fails and prefer 3 is functioning. Or so union. Prefer 1 is functioning and prefer 2 is functioning and prefer 3 fails. So this is the event up described by sets, and we want to find out the probability measure of up. So that is P up. So A complement, the probability measure of A complement is 1 minus, the probability measure of A is A, so this is 1 minus A, and intersection, so here is product, because we are given that all components fail independently, so we know that all this intersection is done on independent events. And inside all these small situations, these four small situations, they do not have an overlapping, so the probability of these two situations is the sum of the four probability measures. So the first situation is 1 minus b times 1 minus b times 1 minus b. And the union is plus, so here is plus. And b, this is b1, no complement here, times 1 minus b times 1 minus b plus 1 minus b times b times 1 minus b plus 1 minus b times 1 minus b times b. And this is 1 minus a times 1 minus b cubed plus 3 times b times 1 minus b squared. And this is the final answer.